So in this section, we would be looking at continuity and differentiability of inverse functions. So if you are new here, welcome. This is the continuation of the module 2 of our calculus 2 class, right? So for a function to be continuous, right, we saw in calculus 1 that the limits of the function as the x approaches from the left should be equal to the limits of the function as you approach from the right? And the two should be equal. Those are the conditions for a function to be continuous. And for differentiability, we saw that f of a should be equal to the limit as x approaches that particular variable, right? We saw that for differentiability as well. Now, for the continuity and differentiability of inverse functions, okay, we only have to show that the function is continuous or differentiable. Then we can conclude that, okay, because your function, right, is continuous and differentiable, then your inverse is also continuous and differentiable. So we have over here, it says that if f is continuous on its domain, okay, remember the domain we spoke about in the first section, where we said any question that we are given that involves a function, we have to include the domain. So once you rewrite the function, you have to include the domain. That was you lose marks because every function, or let me say most functions, are defined on domain. Okay, if you don't bring a domain once a domain has been defined, then you mean the domain for that function is negative infinity to positive infinity, which is in some cases wrong, right? So if a function is continuous on its domain, then the inverse is also continuous on its domain. B says that if f is differentiable at c, and if c is not equal to 0, right, then the function is differentiable at f of c. And this makes sense because if you have a function such as, because if you have the, okay, let me not say this for now. I wanted to make a deduction, but I think we can hold on for now. Yes, so we have a theorem down there which says that let f be a differentiable on its domain and have an inverse function g is equal to the inverse of x. Then the derivative, okay, of g is given by this formula. Right? So this is a formula that you can easily be asked to prove. Okay, this is got from the composite function involving f and g, as we've seen over here. Now they are telling us that you don't have to memorize this formula, and they are absolutely right. So let's see how we can derive this formula from just this composite function that we've been given. So if you don't know what a composite function is a function that is embedded in another function, right? So we have the f of g of x, right? And this is equal to x. This is the function that we are having. This is the relation that we are having. And we learned from calculus 1 again that this derivative, right, is equal to what? The derivative of the outer, okay, multiplying the inner, right? Like not multiplying, but in the composite form of the inner, right, times the derivative of the inner function. And of course, the derivative of x gives us 1, right? Now we make g prime, right, the derivative of g in a subject, and end up obtaining the relation that we saw earlier, which is g prime of x is equal to 1 on the expression f prime, right, f prime, okay, of g of x. This is what we are seeing over here, and that's why you are being told that you don't have to memorize this, right? Leave that space for something else, right? So they are telling us that, and I think it's very true. So let's see what we are left with. So let's Jane show that, okay, so this is a very good question, okay, and this is a typical application question. The question states that, okay, let me cover the solution. But someone asked me that why do you use the solutions that has been solved in the slides before you solve the ones that have not been solved? And the truth is that the ones that have been solved are the ones that stand a higher chance of being repeated. Okay. And when they are repeated, because of where it's from, perfection is needed, right? So I like to take that one first. And also for reference, do you see? Yes, so let's solve this question. This is actually a two-in-one question. Let's G donate the inverse of the function f. Show that the point A, B lies on the graph f. And find G prime of B. Now this is a typical 2025 main calculus 1 exam, and they brought this question. Now the way this question was framed was very confusing, but it's the same thing. Okay, so later we would be looking at the past questions and look at how the question was framed. Now the question is that show that A, B lies on the graph of f. Now, and this is a application question, a typical application question. Okay, so let's try and do this theoretically and let's see how it goes. So we are having this graph. Okay, we are having this graph. Okay, and we'll be given the function. So let's say this function is equal to f of x, right? F of x is equal to what? 2x plus 1. Okay, now to show that this function, remember that f of x, right, is the same as y. Okay, so they are saying that, okay, show that when you put x, right, inside this function, you get this value for y. This is basically everything the question is telling you. So all you have to do is do your substitution. And before you can do that, you have to understand that, okay, when I plot any point on the graph, okay, the x value, right, the ones on the vertical line, so let's say 2, okay, and let's say 5, as we've been given. When I put this inside this function, I should get 5 is equal to these two. So please hope you are getting the trend, right? So let me go over this again. A function, 2 points lie on the same graph if they satisfy each other. That is, remember that this relation is saying they are equal. Okay, so all you have to do is that when you put in the values that have been given to you, right, they are equal. This is everything the question is asking you. And if you can't deduce that, okay, this is what this is saying, you lose marks. Now, find the derivative of g of b. So let's see how we are going to go about it. Remember the formula we solved, I think, about a few seconds ago. Okay, so find g prime of b. Okay, and we saw that g prime of b is equal to 1 on what? F. Is it f? Let me make a reference quickly. Okay, yes, f prime. Okay, f prime. Yes, f prime. So f prime. So the outer one will, wait, where's my? Okay, yes. So f prime of g of x, right? This is what we are having. Now, to solve this, we have to get our g of x. And after we get our g of x, we are going to use that value to find the f prime of that value that we are using. So first of all, we have to get what our g of x is, right? So now what is g of x? What is g of x? This is what we are looking for. Okay, now remember g of x what is equal to g of x, right, is equal to the inverse of x. This is actually a derivative, okay? And this we are saying here is the inverse. Remember the relation we got all these two from f of g of x, and this is giving us x, right? Which means that these two are inverses of each other, because if f of x is equal to what, an x cube, and g of x is equal to 1 on x cube, right? Then f of g of x will give us what, 1, sorry, x. And that's what we are having over here. That's the relation we go over here. So we can say that g of x is equal to what, f inverse of x. So we have this relation down, right? Let's say this is equal to what, let's say a. Yeah, this is a very powerful relation that we are having over here. Yes. Now, we have been asked to find what, g of b, right? Now, God being so good, the b has been given. Okay. So we are to find um oh, where is it? Okay, this is my pen. So let me quickly rewrite this. This is cute. Yep. So we have g prime of b. Okay, this is equal to what, 1 of f prime. Okay, of g of b. Now, we were given the coordinates 2, 5. So g of 5, right? G of 5. Oh, yes. Now it's up to us to find the value of g of 5. This is basically what we are doing. Find the value of g of 5. And remember what we were doing earlier here before. Right, so let's see if you can use this relation to find the value of g of 5. Now, from this that we have, right, and what we did earlier, okay, so we can say that f of x, sorry, f of e, okay, is a, right, is equal to what, x. Remember, our x is what, our x is a 5, right? Our x is a 5. So let's say f of a particular variable a would be equal to 5. Now, from what we saw, okay, we saw that f of 5 is equal to 2 multiplying multiplying x plus 1. Okay, and when the value of f of x, okay, or f of a variable, please, I ain't seen the relation. When the value of f of x or f of a variable is 5, then the x value that gives us that relation, what, is 2. That's what we are seeing over here, and it was given to us in the question. Therefore, g of x, g of 5, right, is equal to 2. So we have what, g, oh no, g prime of b, and this is equal to 1 on f prime of 2. Now we have f prime of 2. What does f prime means? The derivative of 2. So all we have to do is what? All we have to do is to find the derivative of our f, right? Now we have been given f as what? 2x plus 1. So f is equal to 2x plus 1. F prime, right? The derivative of x is equal to what? 2. Okay. Now remember that there is an x to the power 0 over here. So when we make our substitution, okay, we still end up getting g prime of b is equal to what? 1 on f prime of 2. So we are going to put 2 wherever we see what? Rx. right? And 2 to the power 0 is 1. So of course, this gives us what? 1 j prime of b, right? Now the b was given to us as 5. So j prime of 5 should be equal to what? 1 and 2. Okay. So let's quickly go over this. This is the relation that we saw earlier, right? And from this relation, we concluded that we could um get our 5, right? Our 5 was given us in the question because we were asked to find g of b, and we were given the coordinates 2, 5. So this is where we got that 5 from, right? This is x and this is y, right? So that's where we got the 5 from. Now we have to find a g of 5. Now g of 5, we know that g is the inverse of f. That's why we got this relation. G is equal to the inverse of f. And we say, okay, let this be equal to a. Now, from the relation we saw in the previous video, we saw that, okay, if the inverse of f is equal to a particular variable a, we can take off the inverse and make the substitute and make the swapping. Okay, and we saw that, okay, so f of a particular variable will be equal to 5. And from the first solution that we did, we saw that if the value of the function at a particular point is equal to 5, then the point is equal to 2. So that's where we got our 2 from. Now we have to find what? F prime, the derivative of f, using the x value 2. And that's how we got about 1 on 2. Let's see if this is everything we have to do for this. Yes, and actually you can see they had 1 and 2, which is actually a good thing. Okay. Yes, they had what we had. They are copying our answer, which is not good. But let's see. Let's see. Yes. So this is the tutorial section, and we won't be doing this in Saturday's class. So thank you if you watched it to this point. Thank you very much. And see you on Saturday. But I think there's one more video, so please let's try and finish it.